Hello, good afternoon all. So today we are going to discuss one time domain response for a RC circuit. So just we take single RC circuit, first one, then we'll go to proceed to the little bit complex circuit. So let's see. Let's single RC circuit. Okay. So suppose one RC is there and we have to time domain, we have to see the response for V out. If we give the Vi, suppose 0 to 5 volt, so what will be the response of V out in time domain? And we don't write, usually we don't write the equation, we try to just simplify, or we try to get the result intuitively. So let's see how we'll get the result. Now first we'll see that R and C is a first order circuit, one energy storing element is there. And one more thing, we know that C, so at the t equal to 0 or very high frequency, that capacitor has low impedance. So if we see capacitor has low impedance, means initially capacitor will short to circuit to 0 like that. So this is R, this is Vi, this is V out. So Vc 0 minus is equal to Vc 0 plus equal to 0 volt, because, and from one more thing you can tell that capacitor voltage cannot change initially. So since we have not mentioned anything, so we assume that capacitor is charged initially with 0 volt. So at the instant of time, means instantaneously capacitor voltage cannot change. So that at t equal to 0 minus, what was the capacitor voltage? At t equal to 0 plus also same 0 volt. And now at t equal to infinity, capacitor will be open circuit. So at t equal to infinity, capacitor will open circuit. So this is the V out. So if you see Vi, so Vc infinity or V out infinity, same thing, equal to around, so just 1 minute. So Vc infinity, and that is equal to V out infinity. So little bit this is okay. So V out equal to infinity, Vc infinity or V out infinity equal to V out infinity equal to Vi, that is 5 volt. So this is the thing. Now one more thing we can see, suppose our time constant is RC. So if so, from other way also we can visualize, or we can get the solution, we can analyze the circuit. This is the open circuit and short circuit by that we have done. Now at t equal to 0 high frequency, initially capacitor has very low impedance. If capacitor has very low impedance, then what will happen? Capacitor impedance is very low, that means capacitor is going to near short, and V out initially, or capacitor charges to 0, so V out initially 0. Now over the time capacitor will get charge. Now when over the time capacitor will get charge, capacitor will keep on charging, and this V out voltage will be increased. So what will happen? Initially capacitor is 0 volt, then capacitor will charging and capacitor voltage will increase, and since V out also increase. And now the initially what is the current now? Then if we know what is the current, this IR current. So what is the IR current initially? If capacitor is 0 voltage, then current is 1 by R. Now when over the time when capacitor going to charge more and more volt, the current will be reduced. So current also reduce. Now when capacitor is fully charged to 5 volt, when capacitor is fully charged to 5 volt, that means that current will be 5 minus 5, that IR should be 5 minus 5 by R, that is 0, like that only. So this is the current and this is the Vout. Okay, this is the response. So that is the one RC circuit we have analyzed. Okay, thank you.